Hi there, Turgeon here, bringing you physics from afar. We got a quiz. Here are some hints from the Monday results to help you with the Tuesday results. Things I noticed while going over the mistakes that people were making, some of the strengths and weaknesses. So, in particular, thermal energy doesn't really ever doesn't automatically go up just because heat flowed. It probably will go up in one particular object. But think about it like this. If temperature ever goes up for a given object, that means thermal energy will go up. So if I were to heat up a car engine, the thermal energy of the car engine will go up and the temperature will go up. Does the heat go up? Not really. It just means that the thing absorbs some heat to make that happen. What about heat? What is it? Heat happens whenever you have two objects that have different temperatures. It flows from high temperature to low temperature, period. It'll happen naturally. Um, go over the equation. Do some practice. Find those problems. Do some practice. Some of you didn't know how to do that. So if you're given the mass and the change in temperature or the information to find the change in temperature, then what you want to do is look up this specific heat, multiply by the mass, use the equation, but Q is the heat. Remember that Q is the heat. Heat is a flow. Keep repeating that to yourself. Heat is a flow, but it's caused by a temperature difference. Thermal equilibrium, I'm going to talk about that process. Let's go over the notes again really quick. Know these definitions. Temperature and thermal energy are about molecules. Heat is not really about molecules. Heat is about energy flow. Temperature is related to the molecular kinetic energy, so it's related to the speed. If an object's really hot, the molecules going fast. They're moving around with a lot of energy. In thermal energy, the molecules are not necessarily moving around with a lot of energy. It could also have a lot of thermal energy because it's just really huge and has a lot of molecules. This illustrates you got an object with a lot of molecules, even though there's not particularly more energy in each molecule in this sample. It's got more thermal energy because there's more total kinetic energy in this one than there is in this one. Notice in this one, it's got higher temperature because the individual molecules are moving faster, have more kinetic energy. Remember that absolute zero is when, in theory, all motion would stop, even though it's not really possible. Remember that the idea behind specific heat is that specific heat is a type of heat. It's related to raising the temperature. Water is the best example of a high specific heat. So remember, specific heat is the amount of heat to raise the temperature. It's about heat and temperature. But if we say that number 4,186, we're talking about a certain amount of heat necessary. Got to be able to answer questions like that. Let's see. This is the kind of example. Look at 106 again. People struggled with that. Now, let's talk about this thermal equilibrium process. Remember, there's a temperature difference in the beginning. I'm going to talk about temperature and I'm going to talk about specific heat and everything. But look, in the beginning, there's a large temperature difference. This is the graph. Ignore the green one, that's just room temperature. Big temperature difference in the beginning. Heat flow is fast. So if I ask you to describe the heat flow, the heat is fast because there's a big temperature difference. Doesn't make sense to say the temperature is fast. Doesn't make sense to say there's a high amount of heat. I think you're really talking about temperature if you say high amount of heat. There's a high temperature in this one. Big temperature difference. But as heat flows, the temperature difference starts to disappear. And the heat flowing from the hot to the cold makes the cold warmer. Eventually, they reach the same temperature, and since there's no temperature difference anymore, the heat flow stops. This has been Turgeon with some hints. Physics from afar.